Let's dive right in. Number 5. The Monty Hall problem. Picture this: you're on a game show, staring at 3 doors. Behind one is a brand new car, but behind the other 2 are goats. You pick door number 1. The host, who knows exactly where the car is, opens door number 3, showing you a goat. Then he asks, do you want to switch to door number 2? It feels like a 50-50 shot, right? It's just your door and one other. But here's the twist: you're actually better off switching. In fact, switching doubles your chances of winning the car. Your odds jump from 1-3 to 2-3 if you change your pick. This puzzle isn't just a fun brain teaser, it has a history of stumping some seriously smart people. When Marilyn Vos Savant, who was once listed in the Guinness Book of World Records for having the world's highest IQ, explained the correct answer in her column in 1990, she was met with a flood of angry letters. Around 10,000 people wrote in to tell her she was wrong, and about 1,000 of those letters came from people with PhDs. It's a classic case of how our gut feelings about probability can lead us astray. Number 4. The Banach Tarski paradox. Imagine you have a solid ball. Now, what if I told you that you could cut that ball into a handful of pieces, and then, without stretching or adding anything, reassemble those pieces into 2 balls that are identical to the original? Sounds impossible, right? But in the world of theoretical mathematics, it's a proven theorem. This is the Banach-Tarski paradox, and it messes with our everyday understanding of a lot of things, including volume. The secret lies in the fact that the pieces it's cut into aren't like anything you could create in the real world. They're incredibly complex, scattered collections of points. The paradox relies on a mathematical concept known as the axiom of choice, which allows for the existence of these bizarre, non-measurable sets. Think of it this way: mathematics allows for ideas and objects that are far stranger than anything we can physically hold, and this paradox is a perfect example. One version of the theorem even suggests you could take a pea-sized ball, cut it up, and reassemble it into a ball the size of the sun. Number 3. Hilbert's Grand Hotel. Imagine a hotel with an infinite number of rooms, and every single room is full. Then a new guest arrives and asks for a room. You'd think they're out of luck, but not at Hilbert's Grand Hotel. The manager simply asks the guest in room 1 to move to room 2, the guest in room 2 to move to room 3, and so on. Since there's no last room, everyone just shuffles down one, and room 1 is now free for the new guest. This thought experiment, introduced by mathematician David Hilbert, is designed to show just how strange the concept of infinity is. But what if a bus with an infinite number of new guests shows up? Still not a problem. The manager just asks every current guest to move from their room, let's call it N, to room 2N. So the guest in room 1 moves to room 2, the guest in room 2 moves to room 4, and so on. Suddenly, all the odd-numbered rooms are empty and ready for the new arrivals. It's a mind-bending puzzle that shows how full doesn't mean the same thing when you're dealing with infinity. Number 2. Russell's Barber paradox. Here's a riddle that shook the very foundations of mathematics. Imagine a town with a barber who shaves every man who doesn't shave himself. The question is, who shaves the barber? If the barber shaves himself, he violates his own rule because he only shaves men who don't shave themselves. But if he doesn't shave himself, then he fits the description of someone he should shave. It's a brain-twisting loop with no logical answer. This puzzle, created by philosopher and mathematician Bertrand Russell, isn't just a clever riddle. It exposed a major flaw in what's known as naive set theory, the idea that you can create a set based on any well-defined rule. This paradox showed that some rules, like the set of all sets that do not contain themselves, lead to contradictions. Russell's discovery forced mathematicians to rethink their approach to the fundamental principles of their field. Number 1. Simpson's paradox. This one is a real head-scratcher that shows how statistics can be incredibly misleading. Simpson's paradox is what happens when a trend that appears in different groups of data disappears, or even reverses when you combine those groups. One of the most famous examples of this happened with graduate school admissions at UC Berkeley in 1973. When looking at the overall numbers, it seemed like men were being admitted at a much higher rate than women, suggesting a gender bias. However, when statisticians looked at the data department by department, they found a different story. It turned out that women were more likely to apply to highly competitive departments with low admission rates for everyone, while men tended to apply to less competitive departments with higher admission rates. In fact, when broken down by department, the data actually showed a small but statistically significant bias in favor of women. It's a powerful reminder that looking at the big picture, without considering the underlying factors, can lead you to the wrong conclusion. If you liked getting your brain twisted, subscribe and hit the bell. I've got more of these brain-bending lists coming up. Which paradox messed with you the most? Tell me in the comments.